Hello Year 12, welcome to the third and final video here for Locus and the Parabola. We're looking at a simple but very important translations of the parabola in this exercise. What that means is we take our parabola and we shuffle it side by side, up and down. What we're really going to be looking at in particular is the location of the vertex. Instead of having the vertex at the origin, we're going to talk about the vertex being at the coordinates hk. And for that to happen, we replace x with x minus h. We replace y with y minus k, and that's going to translate, right? Move not just the vertex but the whole parabola. Okay. So these things normally require a sketch. Will also require us to calculate typically the focal length, and let's see how that works. Example 6 here, write the equation of the parabola. We've got the vertex, we've got the directrix. Now, my directrix is a horizontal line, y equals -1, and that's important. That means that our parabola is concave up or down. Let's draw in. Oh, come over here. Where's my cursors? Here we go. We're going to call this y equals -1. That's our directrix. And our vertex is something above that. So we can draw in our axes. Not very tidy, I'm afraid. Right, that's our x-axis. Now y-axis here. Now, a vertex is at 3, 1. So 3, 1 over here. Let's put it here. Means that my parabola, help me. Parabola looks something like this. A little like that. So there's 3 there, 1 there. Now, that's not, well, it's generally indicative. That's going to get us through a lot of our trouble. My focal length is the distance from the vertex to the directrix. Right? That's certainly one way to look at it. That's a equals 2. It goes from 1 to -1. That's going to help us. It's concave up, and we know that the vertex at 3, 1. Well, we're just about ready to write this down now. Although the sketch, I'm sure, as scruffy as it is going to help us out. So we have something in the form of x squared equals 4ay, or in this case, x minus 3 squared equals 4 times 2, right, 4a. So that's 8 outside of y minus 1. Remember, we replace x with x minus 3, right? X with x minus 3, y with y minus 1. We get this. Now, look, that's probably good enough there. We can expand it out, though, and we could say that x squared minus 6x plus 9 equals 8y minus 8. And then we could say x squared minus 6x minus 8y plus 17 equals 0. Now that equation there of a parabola with a vertex at 3, 1, and a directrix of y equals -1 is not necessarily apparent from that equation, but we know that we can go from that description to that equation of a parabola, and what do you know? We're going to now go from an equation like that to a sketch and a description of a parabola. And that will finish us off. Let's see how we go. So here we go, a parabola of x squared minus 6x plus 2y plus 12 equals 0. We need to sketch it, we need the focus, directrix, and the vertex. So what do we need to know here? I think we can get straight into doing a little bit of analysis, a little bit of writing down here. And I'm going to separate the x's and y's and say that x squared minus 6x equals -2y minus 12. That makes it a little clearer, I suppose, to see that we have an x squared term. So that means my directrix is horizontal, if you like. And also that it is, what's going on here? I have a negative involved there, so it is concave down. Okay, I've got an x squared equals some negative y term, so it's going to be concave down. What else do we know? Well, I need to complete the square and tidy things up, get it into the standard form so that I can read off the focal length and the coordinates of the vertex. That's going to help us with the sketch. So we do that like this. I'm going to say that x minus 3 all squared, right? I'm going to have to subtract 9 to keep that balanced, minus 2y minus 12. Okay, now I'm going to say that x minus 3 all squared equals negative 2y, adding 9 to both sides, minus 3 x minus 3 all squared equals negative 2 outside of y plus, be careful here, 1.5 because I'm taking a negative factor out. Okay, and in that case, we could say if negative 4a equals negative 2, then a equals 1/2. My focal length is 1/2. So I have a vertex at 3, negative 1.5. Okay. Now, because of that negative y coefficient, we can see that it's concave down. My vertex is at 3, negative 1.5. So my parabola looks something like this. And 3, negative 1.5. See here. Oh, that's not exactly what I wanted. And then a horizontal line over here for my x-axis. Okay, so this point here, that's 3, negative 1.5. Right, there's our concave down parabola. What else do we know here? Now my focal length, we said, was 1/2. So in that case, my directrix is going to sneak in here. I might just change colours because it's getting a little crowded there. Right, I think then my directrix will be over here, and that's going to be y equals negative 1. Okay, focal length of 1/2, right, in this case above the vertex, and my focus is going to be here at negative 2, right, at 3, negative 2. And I think that's all the things that we were asked to find, so we should probably just write those down. So, right, sketch it and show those things. I guess we have. It's a little scruffy, I'm sorry, I'm still getting used to this graphics tablet, but look, that does give us the general view. The focus is at, where's that was, 3, negative 2. My directrix is y equals negative 1, and my vertex is at 3, negative 1.5. Rightio, and that's translations of the parabola. Focus, vertex, directrix, and focal length, they're the important things that we really need in this whole unit here on locus and the parabola. They're the core things, this idea of really a focus and a directrix. Okay, if you've got any questions, jot them down. Otherwise, see you in class.